I'm going to attempt to lecture on both sections 13.3 and 13.4 on Sunday of spring break. I'm not sure why I'm doing this, but had to get it done some point, so felt like as good of a time as any. I changed the homework on the syllabus, and depending on when you're watching this video, your syllabus homework might not match up with the homework for these sections. So let me just emphasize that these are the problems that you're going to need to complete when you're doing the homework for these two sections. Some of the problems might actually do in the video, so your homework shouldn't be too terribly long. Chapter 13 is supposed to be a friendly section, a friendly chapter. A lot of what we'll see in chapter 13 you may have seen in some other classes, and what's new to chapter 13 or what's new to you hopefully isn't too terribly hard. When we get into section 13.6, if you have your graphing calculator around, there's some things that your graphing calculator can do for section 13.6 that will make the work less tedious. There's some computations in 13.6 that to do by hand are, not really that fun to do. So if you're going to watch these videos back to back, having your graphing calculator handy is going to be, you'll be happy to have that. All right, so I'm going to go through my class notes for both sections 13.3 and 13.4. My class notes for 13.5 and 13.6, I might not use them as much as I'll use for sections 3 and 4. So if you printed out the notes for sections 13.3 and 13.4, I'm just going to go through them kind of in the order that they're written. You should have your book handy too, because somewheres in the lecture I do some problems from the text, and it's hard for me to show the problems from the text real well on this document camera just because just doesn't show them as well. So anyways, this is a chapter on statistics, and in 13.3 and 13.4 most of what we're going to do is we're going to be given information, and we're going to organize the information either into charts or bar graphs or line graphs or circle graphs, and maybe answer some questions about the data once we have the graphs created, or the author might give us a graph and we'll answer questions about the graph. So section 13.3 is entirely on something called frequency distributions, and a frequency distribution is just kind of a chart that organizes data as much as anything. So a frequency distribution is just a chart of some sort, a chart or a table to organize information. We might call that information data in this particular chapter, but information would be a proper word for data. And as easy of a way to get started is just to do one. So I've created a table of values, and if I read above this, it says 64 families were asked the question, how many children do you have? And then that data was organized in this table. So there's a lot of families, of the 64 families that were surveyed, a lot of them had 0 children, a bunch had 1, a bunch had 2 children. 9 was the most number of children that any family had. No family had more than 9 children. No can't have less than 0 children. And the instructions I say, what I want me to do is just to take the information and organize the data a little bit better. So construct something called a frequency distribution. A frequency distribution is just a chart that organizes the data, and we need to we organize the data in columns, and it makes sense here to make one column for the number of children each family had, and then maybe the second column for the number of families that had that many children. So if I look at my table, I had anywhere between 0 and 9 children. So in my number of children column, I wrote the numbers 0 through 9. I didn't have to go higher than 9 because no families had more than 9 children. And in the column next to it, I wrote the number of families with that column. So if I added up all the families that said they have 0 children, that's 1, 2, 3, 4, 5, 6, 7, 8. There were 8 families that of the 64 families that were surveyed that had 0 children. So next to the 0, I wrote an 8. And then next to the 1, I counted up all the families that had 1 children, and apparently there were 11. And so for every single number of children, I wrote the number of families that had that many children. So I took the data that was organized in this table and made it more organized so I can glance at it maybe more quickly, understand this data. This data it's organized but not as nicely. So a frequency distribution is just a way to take information or data, organize it into a table. Generally, we make 2 columns in a frequency distribution. The first column our author calls the class column, and the second column our author calls the frequency column. Sometimes underneath the frequency column, this is supposed to be over, we write down the total number of occurrences just so I can kind of check. I said there were 64 pieces of information in this table. If I added up all the frequencies, the numbers in the right-hand column, that should add up to the 64 pieces of data. If I added up the number in this right-hand column and it added up to more than 64 or less than 64, then I messed up somewheres. So that's just the beginnings of section 13.3. It's not a terribly complicated section. Mostly we're going to be given information and creating frequency distributions, or we'll be given frequency distributions and we'll be asked questions about the frequency distributions. So this was just a table of values. I took the table of values and I organized it into a chart, and I'm going to call that chart a frequency distribution. Sometimes, if I was going to make my data and I'd organize it, sometimes if I only made each class have only one number in it, then the table might get crazy long. And sometimes it's necessary to make the classes a range of numbers. And our author gives us some examples with that, and this is as good as any. So here's some information in a table again. This has 15 pieces of information, and these 15 pieces of information, basically it's supposed to, 15 families were surveyed, and they answered the question to what their family income was, and a table was generated here that says the family's income in thousands of dollars. So the one family had an income of $31.5 thousand. That would be $31,500. Another family had an income of $16.8 thousand, or $16,800. I saved writing a few zeros by putting the numbers in as decimals, but I don't know how helpful that really was or wasn't. But this data right here is 15 families were asked what their household income was, and this is a household income of 15 families. If I tried to make a frequency distribution like the last one, then it would have every class would have one family in it. So I'm going to group the data, and you need to really be told how to group the data. If you're not told how to group the data, then you can decide for yourself. But our author doesn't ask us to be creative. So our author wants us to make a frequency distribution, but instead of making each number in the data its own row, I need to group the data. And I said, here, let's group and make the first class 16.5 to 22.6. I'm not sure I can write 16.5 to 22.6. So I'm going to blow this up a little bit and make a bigger version of this so my pen will fit. So I'm going to write income and then number of families. So the top is exactly the same. And then our author, or I asked you to make the first class, or the first line of numbers, to have any family that has an income between $16.5 thousand and $22.6 thousand per year. So next to this, I'm going to go through my chart and find any family, any income that fits in there. So if I look at 31.5, that's not in that range. 50.2 is not in that range. 20.5 is in that range. So there's at least one family that has an income in that range. The next number I see is 16.8. That's in that range. And if I continue going through my data, basically looking for any numbers between 16.5 and 22.6, I don't see any more. So next to that bank of numbers, I'm going to write 2. And now I'm going to start and make my next class, or my next row. And my next row is going to not start with the same number that the last row ended with. It's going to increment up by 1. And since I'm using decimals here, I'm going to increment this up to 22.7. And now I have to decide after the 22.7, what am I going to put? What I'm going to do is I'm going to make my gap the same. So I'm going to subtract 22.6 minus 16.5. That gives me 6.1. To this 22.7, I'm going to add 6.1. So I'm going to go 22.7 plus 6.1. That's going to give me 28.8. So this 28.8 is gotten by taking 22.7 and adding 6.1. I got the 6.1 by subtracting 22.6 minus 16.5. So now in this category, I'm going to look for any family that had an income between $22.7 thousand per year and 28.8. These numbers I've used, they're gone already. I don't need to look at them again. So I'm only looking for incomes in the 20s, so these 30s aren't going to make a difference. This 25.3 is in that gap. That 29.6 is bigger than 28.8, so it's not in this row. 24.8 is in this region. 25.9 is in this region. And I don't think any of the other numbers are between 22.7 and 28.8 inclusive. So for the number of families, I'm going to write 3. I'm going to cross these numbers out of my list because I'm not going to want to count them again. My next row is going to start at 28.9. I'm just incrementing up by 0.1 because each of the decimals here is a tenth. I'm going to add 6.1 again. So I'm going to go 28.9 plus 6.1 to make all my gaps the same here. When I do that, I get 35. I'm going to go through and look for any data between 28.9 and 35. That's in that range. That's between 28.1 and 30, 28.9 and 35. This is between 28.9 and 35. That is, and that is. So I've circled, I think, 1, 2, 3, 4, 5. So I'm going to write 5 families next to that. I'm going to cross out these numbers and make my next bank. It's going to start at 35.1. I'm going to add 6.1. So 35.1 plus 6.1, I get to 41.2. And now I'm going to look for any numbers between 35.1 and 41.2. This 37.4 is in that range. 38.7 is in that range. 35.7 is in that range. There's 3 numbers in that range, so I'm going to put a 3 there. And I'm going to do my next extension. Running out of room here, but I'm just dealing with this. Let me just try to squeeze this in. So I must go to 41.3, and from 41.3 I'm going to add the same 6.1. Gives me 47.4. I look through my data, and 41.3, it's at an endpoint that needs to be counted in that class. So I'm going to get 1 in that class. My last class is going to go from 47.5, that actually says 47.5, not that it looks like it. I'm going to add 6.1 to that. And I get 53.6, and that'll be perfect. That takes the last piece of data. I don't need to make my table any bigger or my frequency distribution any bigger because I've incorporated all the data that's given to me in my chart here. Since 15 families were surveyed, I should add up the numbers in the right-hand column. If it adds up to more or less than 15, I messed up. So 2 plus 3 is 5, 10, 13, 14, 15. Adds up to 15, that's perfect. All right, so that's taking data, making a frequency distribution, and I made the frequency distribution have a range of incomes as opposed to just in the last part where I just had one number of children. Now I'm going to answer some questions, and I put parenthetical comments under the questions so you understood what the questions meant, because they're not intuitive. Some of the questions, if you didn't know specifically how the author wants them to be answered, you might answer them differently. So hopefully my parenthetical comments will help you. So the first question is, what's the total of number of observations? That's just the number of families surveyed. That's the 15 pieces of data, or the 15 families that were surveyed. The width of each class, that's the tricky one. It's found by subtracting consecutive first amounts. So I can do something like this. The width of each class can be found by taking 22.7 minus 16.5. Or I could do something like this. I could take 35.1 and subtract 28.9. Or I can do 28.9 minus 22.7. It's just any two consecutive low numbers, first numbers. If you subtract them, they're all going to come out to the same result. So if I did either one of these, 22.7 minus 16.5, I'd get 6.2. If I did 35.1 minus 28.9, I'd get 6.2. If I did 28.9 minus 22.7, I'd get 6.2. Our author calls the class width 6.2 for this particular set of problems. So it's just subtracting the first numbers in any two consecutive rows. The midpoint of the third class, a midpoint is just adding the first and the last number, dividing it by 2. To find the third class, I'm assuming this is the first class, the second class, and this is the third class. So the third class is between 28.9 and 35. To find a midpoint of a class, you add the first number, the lower number, the higher number, and divide by 2. So I needed to identify which class was the third class. It's the third bank of numbers. The midpoint of any class you get by adding the first and the last number, dividing it by 2. On my calculator, I need a parentheses. So I'm going to go 28.9 plus 35 in parentheses, and then divide it by 2. And the midpoint of the class, the third class, is going to be 31.95. So the answer to question 3, the midpoint of the third class is 31.95. 4 says, what's the modal class? Modal means the class with the most number of families, and it could be that you have more than one mode. If in this case the class or the line that had the greatest observation is the family income between 28.9 thousand and 35,000, so the modal class is going to be the third class, the class between 28.9 and $35,000 per year. If there was another group that had 5, I'd say that it's bimodal, and I'd write both classes down. And then if I was going to add another class, that's the last question, I'd go from 53.6, I'd increment that up to 53.7. And for each one of these, we added 6.1. So 53.7 plus 6.1 is going to be 59.8. So the next class would be from 53.7 to 59.8 if I was to add another one. All right, so these questions, like for me, some of them just weren't intuitive. The width of each class, that was not intuitive at all to me. I had to look in the book to figure out what the author wanted, and the rest kind of were for me. Let me flip pages here and see what I have next. What I have next is problem 8 in section 13.3. You don't need to open your text for that because I printed it out for you, but if you opened your book to page 765, problem 8 looks like this. It gives me a frequency distribution without really nice names, and it asks me some questions that I need to answer. First question is, what's the total number of observations? To get the total number of observations, you add up the numbers in the frequency or the second column. So 7 plus 5 is 12, plus 3 is 15, 17, 24, 25. I added up all these numbers and got 25. So I'd say the total number of observations is 25. That's easy for me. The second question isn't easy for me. The width of each class, width of each class you get by subtracting the first numbers in any two successive classes. So I could subtract 50 minus 40. I could subtract 80 minus 70. The width of any class, the width of each class is defined by the difference between the first number in each class and successive classes. I can do 60 minus 50, 50 minus 40. However I do it, if I pick two classes that are next to each other and subtract the first numbers, I'm going to get a 10. To do the midpoint of the second class, I'm going to go to the second line, which is my second class. I'm going to add the first number in that class plus the last number, and divide by 2. I'll use my calculator to get that. So I'm going to go parentheses 50 plus 59 parentheses divided by 2, and I get 54.5. So I would answer C. The midpoint of the second class is 54.5. D says, what's the modal class? The modal is the class. Modal class has the most frequencies, or the highest frequencies. This is bimodal. So I'd say there's two modal classes, the class between 40 and 49 and 80 and 89, because those both have frequencies of 7s. I think once we get up to like trimodal, if there were 3 classes that had a frequency of 7, I'd probably list them all. But if like there are 4 classes that had a frequency of 7, I might just say there's no modal class rather than writing down 4 of the 7 classes or 4 of the 6 classes and calling them the mode. And then what's the next class? Well, I can tell the 99 needs I don't have decimals here, so from the top of one class to the bottom of the next, I'm incrementing up by 1. This 99 is going to increment to 100, and these all kind of go by 9. 49 minus 40 is 9, so if I add 9 to that, I'd get 109. Generally, this is friendly for most students. If it's not friendly for you, and I'm going too fast or not showing enough detail, and then get me in class and have me expand on my lecture, or just come visit me in my office, and I can give you more problems to get you more practice, to get you kind of in tune with what I'm doing if just the few problems I'm doing aren't enough. I picked another problem from the text, and that's supposed to end section 13.3, and all the author wants me to do is take information and make a frequency distribution. I have to understand what this data is, and 56th grade students were given an IQ test, and these are their IQ scores. So what I'm going to do is I'm going to make a frequency distribution. I don't know how long it has to be. Frequency distribution is just a chart. I need a class and a frequency, and each one of these represents IQ scores. So I'm going to just say IQ score for the name of my left column. And then in the right column, I'm going to write the number of children that had that for my IQ score, or that for their IQ score. And the author tells me that I want the first class to be 80 to 88. My next class, I'm not going to go up by decimals. There's no decimals in the chart, so decimals aren't really that necessary. I'm going to add 1 to 88 and get 89. And then I can see the difference between 80 and 88 is 8. I'm just going to add 8 to 89. So I'm going to go 89 plus 8 and get 97. I put a dash there for 97. And I can go through and finish up the left-hand column, or I can simultaneously do the left and the right-hand column. It doesn't matter. Let me simultaneously do both columns. So let me get the right-hand column for the 80 to 88. For the 80 to 88, the numbers 80, 81, 87, and 88 are all in that grouping. There's 4 of those, so next to the 80 through 88 class, I'm going to put the number 4. Then from 89 to 97, that's going to give me a lot. There's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There were 16 children that had IQs between 89 and 97. I'm going to increment up from 97 to 98. Put a dash as opposed to a plus sign. And I'm going to add 8 because the difference between 80 and 88 was 8. 89 and 97 was 8. 98 plus 8 is going to give me 106. I could use my calculator if I didn't know how to do that. And now I'm going to start running through and counting how many IQs were between 98 and 106. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I put a 15 next to the 98 to 106. I increment from 106 to 107. I'm going to add 8. 107 plus 8 is 115. And now find all the how many IQs are between 107 and 115. There's 1, 2, 3, 4, 5, 6, 7, 8. So next to that, I'm going to put an 8. Next class, I increment up 1 to 116. I add 8. 116 plus 8 is 124. And I get 1, 2, 3, 4 in that bank. Next one's going to be 125. Add 8 and get 133. There's only 1 in that category. Need to make my table bigger here, or my frequency distribution bigger, because I haven't got the 135 in there. Last one's going to be 134. 134 plus 8. I get the 8 again because 88 minus 80 is 8. And 134 plus 8 is 142. There's 1 in there. So I think I have a frequency distribution that's perfect. I need to make sure I have all the data. I was told that there's 50 sixth graders that were tested. Let me add up the right-hand column. This right-hand column, if it doesn't add up to 50, I made a mistake. If it adds up to 50, I like to think I did well. I'm concerned that I didn't mark out that 89. Maybe that's going to cause me grief. But let me add these up. I'll just use my calculator. So I'm going to go 4 plus 16 plus 15 plus 8 plus 4 plus 1 plus 1. When I hit enter, if it doesn't say 50, then I have to start searching for a mistake. If it says 50, I think I did perfect. Oh, and it says 49. I suspect that this second number of 16 should be 17 just because I didn't knock that off. So let me go for all the scores between 89 and 97. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And this was supposed to be 17. Now it's going to add up to 50. So it's not the worst thing in the world that I made a mistake. And this is a safe thing to do. Anytime you do a frequency distribution, add up the numbers in the right-hand column. Make sure they add up to the total number of occurrences. If they don't, then you had a mistake somewhere. And fortunately, that mistake was easy to find. I just missed that 89 for whatever reason. So that's the entire section 13.3. The homework problems hopefully tie very nicely to what I did. The homework problems are just the problems 7, 9, 11, 13, 15, 19, and 21. And I'd like to hope that all of them are just having you create frequency distributions or having you answer some questions with regards to a frequency distribution. I'm going to do section 13.4 in the same video. It's equivalently a friendly section. It's maybe there's slightly more. It's slightly more involved, section 13.4 than 13.3, but it's not too bad. So I think I can stick them into one lecture and not have it be like the worst lecture in the world. So in section 13.4, we're going to take frequency distributions and make bar charts, which our author calls histograms. We're going to make line graphs, which our graph author calls frequency polygons, and we're going to make some circle graphs and something called stem and leaf plots, all of which you may have seen in some class before you even got to GCC. So if you printed out the homework or the handout from my notes from section 13.3, you got 13.4 because they came together. And in 13.4, you're just responsible for the 9 through 25 odds. Your syllabus hopefully says that, but it may not. So if it doesn't, you only have to do problems 9 through 25 odds for homework. And I'll wind up doing, I think, a few of those problems in my lecture. So the homework shouldn't be grueling for this section. So in section 13.3, the first example we looked at, there were 64 families were surveyed, and they were asked how many children they had, and we constructed a frequency distribution, or I gave you a frequency distribution that's just a duplicate of the very first thing I did in section 13.3. In section 13.4, and taking the data that was given, organizing it into a frequency distribution is one thing you could do. Another thing you can do is make a bar graph. That's called a frequency histogram, and that's what I'm going to do next. I have a picture of a frequency histogram that I used Excel to generate. Let me draw a frequency histogram, which is just a bar chart. That might be more like our author does. So a frequency histogram is another way to organize data. And it's a bar chart, and our author is very consistent. The first column, the author puts these numbers along the bottom. So the first column stands for the number of children, and those values I'm going to put on the bottom. So I'm going to start at 0, and I'm going to put all the numbers, and then leave myself so much room here. So let me just bust out another piece of paper. That gives me a little more room to do this because I didn't really set myself up for success here. So I'm just going to redo this. So I'm going to call this a frequency histogram. And I'm going to make a picture that looks like the bar chart that I created via Excel. And I'm going to do something more like the author would like to see, but I'm not particularly that picky about frequency histograms. So the number in the the numbers in the left-hand column refer to the number of children. I'm going to write that word on the on the bottom, and on the left-hand side, I'm going to write the heading of the right-hand column. The number of children go from 0 through 9, so I'm going to make a little tick mark for each of the numbers from 0 through 9. I don't have to go before 0 because no family had less than 0 children, and I don't have to go over 9. And now that's the bottom. On the horizontal, or the vertical axis, should I say, I need to get the number of families between between 1 family and 18 families. And I like the way that Excel did it. I could write each number between 0 and 18 on this left hand, or this vertical axis that I've created, but that would really be crunching it. And so what Excel did for me is it gapped these by 5, and I kind of like the way that came out. There isn't anything right nor wrong about what I did in my picture using Excel. You could put each of the numbers between, you can start at 1 and even go up through 18 if you wanted to, or you can start at 0 and go up through 18 if you wanted to, but this seems reasonable. Now, above each number, I'm going to put the number of occurrences the best I can. So for 0 children, there were 8 families, so I need to estimate where 8 is. I made a little dot there. I'm going to connect a bar, and our author does this with his bars. He makes a bar that the number 0, if I go above it, that dot that's at 8 children is directly in the middle, and our author makes the bars connect, so I made it kind of go halfway between each of the occurrences, should I say. The next height, 1 needs a height of 11, so I'm going to go over to 10, up to what I consider to be 11 and make another bar. That dot is right above the 1, and my graph is going to, my bars are going to touch as opposed to what they didn't on Excel. It really doesn't matter if your bars touch or not. Our author makes all the bars touch in frequency histograms, but they don't have to. Above the 2, I need to go up to 18. So I need to estimate the best I can 18 on the left axis, so the vertical axis, and then make a bar. It would be nice if all my bars had exactly the same width. That would imply all my numbers were equally gapped, but they aren't. So my bars might be fatter and skinnier, and that, it is what it is. It's not that important. So I've done 8, 11, and 18. I need to do another 11 above the 3. Above the 4, I need a 6, and I'm just going to estimate 6 the best I can. That little line, I just accidentally drew that. So let me just shade my graphs in so you don't see that ugly line that I drew. You don't have to shade these, but it's not wrong to shade these. Above the 5, I need 4. 4 maybe is about there. Above the 6, I need a 2, and 2 is very low. Maybe it's about here. Above the 7, I need 1, and 1's even lower than that. Maybe that's about there. On the 8, I need a 2, and the 9, I need a 1. So this would be considered a frequency histogram that is maybe more suitable to our author's taste than Excel's taste. But both of these would be perfectly acceptable. Notice on the bottom, I wrote the number of children. The number of children was the numbers in the first-hand column. And when I did it by hand, I wrote the words number of families around the left-hand column. Couldn't figure out how to make Excel do that, so Excel just said, oh, these little bars represent the number of families. That's completely acceptable. There isn't a universally correct way to make frequency histograms, so I have to be really lenient if I'm asking you to grade, if I'm grading a frequency histogram, because there isn't like, this is the only correct frequency histogram. There's many correct variations of these bar graphs. For that matter, your bars can go horizontally. Our authors don't make them go horizontally, but they could. So a frequency histogram is just a bar chart. The next thing the author wants us to make is a frequency polygon. For the same data, a frequency polygon is hardly different than a frequency distribution. Basically the exact same thing, except instead of connecting the data with bars, we connect the data with little line segments. So I'm going to use the same sort of information. I have the number of families, the number of children with those families, and I'm going to do a frequency polygon just like I was making a frequency distribution. Need to start at 0, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9. So along the horizontal axis, I wrote the number of children that the families had. They had anywhere between 0 and 9 children. And then I'm going to do the same gapping because I don't care to increment by 1 to get up to 18. I'm going to take each of the bits of information the best I can, now that I can barely see them, and make a dot above each of the numbers on the horizontal axis. So there were 8 families that had 0 children, so I'll go from 0, I'm going to go up to about where 8 is and make a dot, but I'm not going to make a bar there. Above the 1, but that says 1, believe it or not, there are 11 families, so from 1 I go up to 11 and make a dot. 2, there were 18 families, I figure out where I think 18 is, I make a dot. 3 is 11, so I go up to where I think 11 was and I make a dot. 4, I can't even read that, I think it says 6. I go up to where I think 6 is and make a dot. 5 is 4, I find out where 4 is and make a dot. 6 is 2. 7 is 1. 8 is 2. 9 is 1. I'm just going to connect each of the dots with a line. So I'm going to go a line that connects each of the consecutive points best I can. It'd be probably nice if I used a ruler, but not such a big deal that I don't. This is what I would call a frequency polygon. I just took the data, plotted, I created kind of a two-dimensional graph, actually spell, and I plotted the points and connected each of the points with a line segment. Our author feels the need to extend these graphs, and I think it's probably a flaw of the software package the author used to make the graph. Our author would have this, from the bottom left corner to the first point on the graph, our author shows a little line segment connecting those. Similarly, from the last point all the way, the author would have a point going to the x-axis. If I look at problem 6, which is a frequency polygon, the graph itself probably should end like that, and our authors, for whatever reason, his program that he used to create the graphs, extend the graph to the kind of origin and extend the graph back down to the, which we would call the x-axis. I don't think that's really right. Apparently it's not wrong enough that bothered the author. So if you're creating a frequency polygon and you're checking your answers in the back of the book, the author always will have a point going from the origin to the first point and from the last point to the x-axis. And those points I put in different colors because I really don't think they're right to have there. I think it's just, like I said, a flaw of the author's graphing package that just shows up in the book. I wonder if in the new editions of the book, if that's still there. This is a pretty late edition of the book. I think this is the 7th edition. So must have been there for the other 6 editions, so I doubt that it changed in the 8th edition. So a frequency polygon is a line graph as opposed to a bar chart. Kind of shows the same thing. Our author connects the endpoints, and I don't think that's particularly right. A frequency histogram is just a bar chart. Our authors makes the bars touch. I don't particularly think they have to touch it. I couldn't even figure out how to make Excel make them touch. So I just showed you 2 different histograms. They're both equally correct. I will not be that picky when I grade your test to, if your graphs are a little bit different than mine. Next thing I wanted to do is problem 16 in the text, and then I wanted to do 17 and 20. So I'm going to do 16, 17, and 20. You need to have your text handy for each one of these problems. 16 gives me a table. It's on the bottom of page 775, and I'm asked to make a frequency distribution and a frequency polygon. I see there's a frequency distribution that's given. I see salary and number of people. When I make my frequency distribution and my frequency, or when I make my histogram and my polygon, on the bottom I'm going to write salary. On the left-hand side I'm going to write number of people. And then I'm going to do something slightly inconsistent with our author, but inconsistency that I think is okay. So I'm just going to copy the table from problem 16. The table from problem 16 has one column that said salary, and then I see 30 to 35, And then next to that it says number of people. So just in case you don't have your book right in front of you, this is the table that's in the book. And I'm going to make a frequency histogram or a bar chart as well as a frequency polygon. And my work might be slightly different than the author's because what I write on my axes might be different than what the author decides to write. Like I said, there isn't an absolute must for these problems, so you'll see variations in answers. So part A wants me to do a histogram or a frequency histogram. It's just a bar chart. I'll at least be consistent. The bottom of my bar chart, I'm going to write salary, because that's the left-hand column. And on the vertical or Y kind of axis, I'm going to write number of people. And this is where the author varies from me a little bit. On the x-axis, the author's going to put the midpoint. So the author would, for the 30 through 35 category, instead of writing 30 through 35, the author would put 32.5, which you get by finding the midpoint. The author would go 30 plus 35 divided by 2. And along the kind of x-axis, instead of writing the whole class 30 to 35, our author would write the number 32.5 there. I don't really think that's really that great to do, so I'm not going to do that. I think that almost seems funky for me. So for my x-axis, I'm going to write the whole class rather than writing the midpoint of the class. And like I said, this is really inconsistent with what the author does, but there isn't a right and a wrong way to do histograms. There's definitely room for some variability, and this just looks better to me than what the author does. So I'm happy to write that. But if on your kind of x-axis you put 32.5, 38.5, and found the midpoint of each of these, and rather than writing the whole class, that's completely fine. On my vertical axis for my histogram, I'm not going to have a hard time incrementing going from 1 through 9, so rather than incrementing by 5s, I'm going to increment by 1. You don't have to. You can increment by 2s, you can increment by 5s. There isn't a right nor wrong way to make your vertical axes. It's just kind of what you feel comfortable, what you think is going to fit. And in the last problems, trying to get from 1 to 18 felt like it was going to be a nuisance, so I incremented by 5. On this problem, incrementing by 1 to get to 9 is not that hard. So now, above the first height, I need to go to 4. So right above the dash there, I'll make a 4, and now I'm just going to make a bar. Next dash, I need to go to 7. Hopefully that's actually at 7. Make a bar. I'm making my bars connect, but you really don't have to make them connect. Next bar goes to 8. Be nice if my bars were all the same width, but I'm not going to take points off if they're not. It's just not that crucial. Next bar at 9. Then at 7 again. It would be nice if this 7 and that 7 were at the same height. Then at 5. And then lastly at 3. So that would be considered a frequency histogram. I could start completely over and do a frequency polygon, which is a bar chart on a completely new graph. If you peeked at the author's answers in section 13.4 and looked at his pictures of frequency histograms and frequency polygons, you'll see that the author got a little bit lazy, and I kind of like his laziness. So I'm going to be consistent. So these are kind of the bar graphs that the author made. And you'll notice that the bar graphs that the author shows in section 13.4, the author also shows the frequency polygon right on the same graph. So instead of making a separate graph for the frequency polygon, I can superimpose the frequency polygon and frequency histogram on the same graph. So basically, I'm just saving space here. So I'm going to make a frequency polygon, which is just connecting each of the segments, each of the pieces with a line segment as opposed to a graph or a bar. So the points that I connected, the points that I used to make my histogram, I can just connect and call that a frequency polygon. So I'm going to say my frequency histogram is in pink. My frequency polygon is going to be in blue. So I'm just going to connect the points rather than making a whole entire new graph. That would be considered a frequency polygon. That's kind of ultra lazy, but since our author used that laziness, I think that laziness is fair to do. That's just a bar chart. I could have reproduced this whole graph, rewriting my x and y axis numbers, and then just not drawing the bars instead of connecting the points with bars connecting them with line segments. If you look at our author's answer, our author would do this and this. Our author would have a point going from a line segment going from the origin to the beginning of the graph, and from the end of the graph he would have a line going to the x-axis. I don't really think those are right, but if you put them there, it's completely fine. So that's a frequency histogram and polygon all kind of superimposed on top of each other. Hopefully that wasn't too much to do at once. If you feel uncomfortable with that, I can do them separately in class or separately in my office. Come visit me, and I'll help you the best I can. So I'm also supposed to do problems 17 and 20. In 17 and 20, kind of need to have the book just handy. So I probably couldn't reproduce those as nicely as I'd like to reproduce those. So I'm going to bring problem 17 up. I'm going to blow it up the best I can, but it would be nice if you had your book in front of you so you could actually read along. So that's the best I can do. So if I look at this problem 17 without looking at the questions, I see a frequency histogram or a bar chart and the number. So basically, people were surveyed at some movie theater and asked how many soft drinks they purchased, and people purchased between 0 and 6 Cokes, Pops, whatever you want to call them. And so there were 2 people that were surveyed that didn't purchase any sodas. 7 people purchased 1 maybe for themselves. 8 purchased 2 sodas. And 1 person purchased 6 sodas. Maybe they came with a group. Maybe they have kids or something. So this chart, this histogram that's given, basically said how many people and how many sodas they purchased. So you have to understand what the histogram has given you before you can possibly answer questions. So question A says how many people were surveyed. In order to figure out the number of people surveyed, I have to figure out how many people did each kind of drink. So we have a number of drinks and number of people. And anywhere between 0 and 6 drinks were purchased. How many people did 0 drinks? There were 2 people that did 0 drinks. How many people did 1 drink? It looked like there were 7 people that did 1 drink. How many people bought 2 drinks? There were 8 people that bought 2 drinks. How many people bought 3 drinks? It looks like there were 5 people that bought 3 drinks. There were 4 people that bought 4 drinks. There were 3 people that bought 5 drinks, and there was 1 person that bought 6. So for each of these bars, I found out the height of the bar, because the height of the bar is the number of people that bought that many drinks. Now if I add up the number of people that I have, 2 plus 7 is 9, plus 8 is 17, 22, 26, 29, 30. I believe 30 people. The answer to question A, how many people were surveyed? I would say there were 30 people surveyed. Basically, each height represents the number of people that had that many drinks. I added up all the heights and I got 30 people that were surveyed. Part B, how many people purchased 4 soft drinks? That's quite a bit easier of a question. How many people purchased 4? So this is 4 soft drinks. I go up to the top and I go over. It looks like for part B, there were 4 people that purchased 4 soft drinks. I wonder on that last problem when I showed it, you didn't see the whole thing. On that last answer, just in case you wanted to see the end of what I wrote, I next to each number of drinks, that actually says number of drinks, not that I could barely read that now, I found the number of people and then I added those up. Part B, the number of people that purchased 4 soft drinks. I went to the column that represented 4 soft drinks, went to the top, then I went over to the column that said 4 people. Part C, what's the modal class? The modal class is going to be the class, the highest class. The modal class is going to be 2 soft drinks because that's the highest bar. So part C, the modal class is the 2 or the 2 soft drinks. Part C, how many drinks were purchased? Fortunately, when I did part A, basically answered part. Oh. No, that's tricky. I thought it would. I almost messed up. Part D is very tricky. How many soft drinks were purchased? Let me recreate this table that I created. I created a frequency distribution from the data. And my frequency distribution said number of drinks, number of people. I had 0 drinks for 2 people, 1 drink for 8 people, 1 drinks for 7 people, 2 drinks were 8 people, 3 drinks were 5 people, 4 drinks were 4 people, 5 drinks were 3 people, 6 drinks were 1 person. I get a total of 30 people. So there were 30 people, but that were surveyed here. And how many drinks did they buy total? Well, it's more than 30 drinks. How do I figure out the number of drinks? I'm going to multiply and add. There were 0 people, 2 people that bought 0 drinks. So that would be a total of 0 sodas. There were 7 people that bought 1 drink. If I multiply 7 people times 1 drink, that's the 7 drinks that they bought. 8 people bought 2 drinks. I'm going to take the 8 people times the 2 drinks that they bought. That's a total of 16 drinks. If I multiply the 2 drinks by the 8 people that bought those, they bought a total of 16 drinks. 5 people bought 3 drinks. So if I take each of the 5 people, multiply by the 3 drinks that they bought, those 5 people purchased 15 drinks. Then 4 times 4 is 16, 3 times 5 is 15, 1 times 6 is 6. So this is a number of drinks total. If I add these up, 0 plus 7 is 7. This is calculator worthy, so let me break my calculator out. So I'm going to add up 0 plus 7 plus 16 plus 15 plus 16 plus 15 plus 6. And I get 75 total drinks. So the answer to how many drinks were purchased in part D is going to be 75. So this is the answer to part D is 75. And part C wants me to do a frequency distribution. I already did a frequency distribution when I did part A because I wanted to organize my data before I could answer the questions. For me, it was hard to answer the data from the frequency histogram. So I made a frequency distribution already. So you need 2 columns. The word along the bottom is number of drinks. The word along kind of the y-axis is number of people. And I just created my frequency distribution. And that should also be the answer then for part E. This is the picture that's needed for part E. So I said I was going to do 17. I wonder what other problem I said I was going to do. I think probably something that's real similar. 18 is kind of oddly tricky, so I didn't do that. And then 19, as a homework problem, I'm going to do 20. So 20 is a similar question in that it gives me a picture, in this case a frequency polygon, and it wants me to answer questions, so I need to understand that frequency polygon. I'm going to make a frequency distribution out of it right up front. So the polygon, the bottom it says number of visits to the San Diego Zoo, and then it says the y-axis kind of says the number of families. This first point and this last point are garbage, and it says how many visits? 1 visit. So the visits are between 1 and 10 visits. So the numbers along the bottom represent how many times somebody went to the San Diego Zoo. They went either, every family surveyed went between 1 and 10 times to the San Diego Zoo. So maybe they just were surveying people at the San Diego Zoo. So people, assuming at the San Diego Zoo, were asked, how many times have you came to the San Diego Zoo? And their results are in this picture. The first thing I see is above the one that's 4. That means 4 families said we went to the San Diego Zoo, just as our only visit to the San Diego Zoo. And then the second dot above the 2 is at 2. This says 2 families says they came to the San Diego Zoo twice. The next dot above 3, it looks like it's at a height of 8. 8 families said that they came to the San Diego Zoo 3 times. And then the next dot above 4 is also at 8. 8 families said they came to the San Diego Zoo 4 times. And then above the 5, it looks like it's at 6. 6 families said they came to the San Diego Zoo 5 times. Above the 6, it's 11. 11 families said they came to the San Diego Zoo 6 times. And it looks like 9 above the 7. 9 families said they came to the San Diego Zoo 7 times. Above the 8 is a 3. 3 families said that they came to the San Diego Zoo 8 times. Above the 9, no family said they came to the San Diego Zoo 9 times. And above the 10, 1 family said they came to the San Diego Zoo 10 times. I would consider this a completely adequate frequency distribution. So creating that frequency distribution helped me understand what the data gave me. So the numbers in the bottom are the number of times a family came to the San Diego Zoo. The numbers in the right of the vertical axis are the total number of families that came that many times. Let me add these numbers up because I'm probably going to need that anyways. So I'm going to add up 4 plus 2 plus 8 plus 8 plus 6 plus 11 plus 9 plus 3 plus 0 plus 1. I get 52. So it looks like 52 families were approached at the San Diego Zoo and asked how many times they came to the San Diego Zoo, and that's their answers to that, how many times they came. So now, how many families came to the San Diego Zoo 4 times? I go to the number of visits, the number of families. So if I wanted to answer question A, how many families came to the San Diego Zoo 4 times? 8 families came to the San Diego Zoo 4 times, because above the 4 I go over and there's 8 families. Part B is a little bit trickier. Part B says how many families came to the San Diego Zoo at least 6 times. That's 6 or more times. So for part B, I'm going to add up the families that went 6 or more times. That's all of these to do part B. So 6, 7, 8, 9, or 10 times. I'm going to add up those number of families. And for part B, I'm going to add, those are all the families that came 6 or more times. When I add those up, 11 plus 9 plus 3 plus 1, I get 24 families that came at least or 6 or more times. How many families were surveyed? I already added all these up in my frequency distribution. That's 52. Part D, I've already done the frequency histogram distribution. part E wants me to do a frequency histogram. I'm going to cheat on my frequency histogram. I'm going to use the author's work and make a histogram basically right on top of that. So to do my frequency histogram, I'm going to take the author's picture and make a bar chart. So I'm just going to connect the points with bars the best I can. Probably not what the author desired me to do, but I didn't feel like replotting these points, and that's all that a frequency distribution and a frequency polygon are not radically different at all. They all have the same points that are plotted, and a histogram, instead of connecting the points with little line segments like you would in a polygon, in a histogram you make a bar chart. So that would be the answer to part E. That would be a perfectly adequate histogram for that particular problem. So that's the end of that little bank of problems. The last thing that's left in the section is stem and leaf graphs, or stem and leaf plots, stem and leaf displays. Different authors will say different words for these same things. And a stem and leaf display or a stem and leaf plot is just another way to organize data. And it's a way to organize data that kind of breaks up the digits. So the number 53, when we do a stem and leaf plot, the 5 and the 3 are going to be separated. The 5 I'm going to call the stem. The 3 I'm going to call the leaf. The number 483 can be broken up into the stem of 48 and the leaf of 3, or a stem of 4 and a leaf of 83. 6, because it doesn't have a 10 part, we can say its stem is 0, its leaf is 6. A stem and leaf plot, again, it's just a way to organize data. And this problem here is a bunch of data. 20 people at the Yard House were asked how old they were, and this is the list of information. And then I said, make a stem and leaf plot. I looked at the information. The smallest number I saw was 20-something. The biggest number I saw was 70-something. And I made a column that I called STEM for people in their 20s, 30s, 40s, 50s, 60s, and 70s. And now I started making the leaves. After the 2, I'm going to write any person that was in their 20s. There was a person that was 27, 28, and 29. The 7, 8, and 9, so that's the 27-year-old person, the 28-year-old person, the 29-year-old person. After the 3, I have a 1 for the 31-year-old, 2 for the 32-year-old, 9 for the 39-year-old. That's all the people that were in their 30s. I like my leaves to be in ascending order, but if you wrote 921 or 219, it wouldn't matter. But I'm going to be consistent. I'm going to make my leaves go in ascending order. Now next to the 4, I need any person in their 40s. And what do I see here? I see 43, 44, 44, 45, and 47. So next to the 4, I'm going to write 3 for the 43-year-old, 4 and 4 for the 2 44-year-olds, and then 45 and 47. So that would be the proper leaf next to the 4. Now I'm going to do the 50-somethings. So there's a 50, a 59, a 58, and a 56. I'm going to write 0 for the 50, 6 for the 56, 8 and 9 for the 58 and 59. And now I'll do the 60s. That's 60, 62, and 68. So I'm going to write 0, 2, and 8. And then for the 70s, I see a 71 and a 72. So this would be a completely adequate stem and leaf display or stem and leaf plot for the 20 people that were asked at the Yard House how old they were. And we're not going to do much with stem and leaf displays at all except create them. So let me dig a problem out from the text and show you what you're kind of responsible for. So in the text, we'd be responsible for something like problem 24. And problem 24 in section 13.4, let me just show it up here. It says distance to work. 20 workers at a small company were asked how many miles they drive to work one way. Make a stem and leaf to spot. For single-digit data, use the stem of 0. So if I look at this problem, not that you can see it so far, well, the shortest distance anybody went to work was 2 miles. The longest distance anyone went to work was 41 miles. So in my stem and leaf display, I'm going to start with 0 and go up to 4. 0 for the people that were under 10 miles, 4 for the person that went 41 miles to work. And I'm not going to label these too terribly interesting. I'm going to label one stem and the next the leaf. And I'm going to go stem, leaf. I think our author might say leaves. And there's people that went under 10 miles, people that went between 10 and 19 miles, 20 and 29, 30 and 39, 40 and 49. So now I'm going to go through the data and find all the people, all the mileage that's appropriate. So in problem 24, the single digit miles, there was somebody that went 3 miles, 8 miles, 2 miles, and 5 miles. I just took that from the data because you might not have the data in front of you. And my leaves next to the 0 are just going to be 2, 3, 5, and 8. Next thing, I'm going to go through my data and find all the people that went between 10 and 19 miles. Hopefully I get them all. I see 12, 18, 12, 15, 13, 17. Let me just write those down so in case you can't see them. The numbers I see in that bank, I see 12, 18, 12, 13, and 17. My leaves next to the 1, I'm going to have 2 2s for the 2 12s. I'm going to have a 3 for the 13, and a 7 and an 8 for the 17 and 18. I'll look through my data for all the 20 miles, and I see 25, 21, 22, 27. Oh, I missed 16 for the last one, and I missed 19. Oh, let me add the 16 and 19 to my leaves. A cheat here. You don't have to have your leaves in order. I prefer them in order, but since I messed up and I didn't want to scratch it out, I just put the 6 and the 9 after. It's not wrong. Usually I'd make my leaves go in ascending order, but because I forgot some data, because in here I missed a 16 and I missed a 19, and that made my answer kind of wrong. So I fixed it badly, but I fixed it. Might be nice if I erased it and did 2, 2, 3, 6, 7, 8, 9, but it's not wrong to have your leaves in non-ascending order, so I'm going to leave it like that. Getting back to my 2s, hopefully I get them all. I see 25, 21, 22, 27, 23. I think that's all the 2s. Let me write these down. So I see 25, 21, 27, 22, 23. Next to the 2, I'm going to write 1, 2, 3, 5, and 7. For the 30-somethings, the people that drove over 30, the only ones I see are 33 and 34. So I'm just going to write a 3 and a 4. And next to the 4, there was only one person that went over 40 miles. They went 41 miles. I'll put a 1 next to the 4. That's all we're doing with stem and leaf plots. We're just taking the information that's given, breaking it up. Really, it's 10s and it's 1s. I think that's all we're going to do in terms of a test is break data up into its 10s and its 1s. And that it kind of is what it is. Hopefully you've seen that before, and the 2 quick little problems is enough. The last thing we're doing are pie charts, and I wrote our circle graph. Circle graphs and pie charts are interchangeable. So if I say circle graph or I say pie chart, they mean the same thing. And we're going to create pie charts, and I believe answer questions given a pie chart. Now, I think maybe we're just going to create pie charts. We're not even going to answer questions from them. although I think we will, so maybe I'll go back and do, yes, we will. So I'm going to do answering a question from a pie chart. So how do I create a circle graph or a pie chart? I take the information that's given. The information that's given in this little sheet, 600 people were asked what kind of movie they went to, and we broke the movies down into actions, comedies, dramas, science fiction, and romance. So there were 600 people that came out of a movie theater out in Westgate, and we just said, we could have asked them what movie they saw, and then we could have categorized that. But anyways, of the 600 people, they all went to some sort of movie, and we broke them down into categories. Now I want to take that information and make a pie chart. How am I going to make a pie chart? Well, I need to figure out how big to make each section. For me, it's easier to figure out how big to make each section using percents. Some people are real comfortable with circles and degrees, and they can get the same thing accomplished with degrees, but I won't really touch on degrees. So what I did is I took the number of people in each category, divided it by the 600 total people, multiplied it by 100. So I did 230 divided by 600, gave me a decimal, multiplied by 100, made it percent. So 38.3% of all people, of the 600 people, saw action movies, 25.7 saw comedies, 16.5 saw dramas, and I did all the percents, and now I'm going to make a circle graph. And I had Excel make a circle graph for me. It's going to be way nicer than I'm going to do by hand. I don't know why I just made a square. Don't really need a square for a circle graph. Well, let me just make a circle for a circle graph. So to make a percent into a degree, if you're used to degrees, you multiply the percent times 360. That will make it into degrees. A circle has 360 degrees. I'm not going to focus on this. I'm going to try to make a circle graph that represents these percents. And for me, half a circle is 50%, a fourth of a circle is 25.7%. This part right here, I could draw that more accurately than any of the kinds of movies. 25.7% is just slightly bigger than a quarter. So I'm going to go from the center and make a segment that's just a little bit bigger than a quarter of the circle. Maybe I'll write in here too. I'm going to write comedy, 25.7%. And that's kind of what our author would do. So I'm done with comedy, and now everything else I'm just going to make relatively okay. The biggest section needs to be action. 25%, 50% is the whole way. 25% is a quarter of the way. 38% is more than 25%, so it's more than a quarter. It's less than 50%, it's less than a half. And the best I can, I'm just going to estimate. This region right there is bigger than a quarter, it's less than a half. I'm going to call that 38.3%. It's not necessarily perfect, but it's going to be close enough for my purposes. So now I've gotten action and comedy in. The next biggest region needs to be drama. It's less than a quarter of the circle, so I can make it less than a quarter. And it needs to be the next biggest section. And 16.5% is, I don't know, I'm just guesstimating now. And I don't even know how great of a guesstimate that is, but I'm not breaking out a protractor or doing anything more complex than just guesstimating. It's more than, it's, less than a quarter. So maybe that's not even quite big enough, but I'm living with it. My next region can't be as big as that because 15.2. Well, let me cheat here. Let me break the pie up into 3 sections for the 3 pieces I have left. The biggest of the 3 sections needs to be drama. The next biggest needs to be science fiction. Science fiction and drama should be a little bit closer together than that. If I look at my beautiful Excel picture, you can see the science fiction pie and the drama pie. Boy, they're almost the same size. The drama should be a little bit bigger than science fiction. My picture's kind of screwed up here, but I'm not just looking for that kind of accuracy. Let me call this drama and call it 16.5%. Let me call this sci-fi, call it 15.2%, and I'll call this the last region romance, and I'll call it 4.3%. Honestly, I'm never going to do a pie chart by hand because it's not hard at all to get some sort of program to make a pie chart. So if I'm asked to do a pie chart and I'm getting paid for it, if I want something that's going to be a really nice picture, I'm going to enter the data and have somebody teach me how to do it on Excel. You can watch a YouTube video to make a pie chart on Excel if you don't know how to do it. If I'm asked to make a pie chart by hand, I'm not expecting it to be crazy accurate. The part that has the highest percent should be the biggest. The part that has the lowest percent should be the smallest. And we'll just kind of fudge a little bit and call this reasonable. You'll notice that my sci-fi and my drama, my sci-fi is probably way too much smaller than my drama. I probably should tweak this line over. If I did this in pencil, I could have erased this and brought this line over so these two sections were about the same size, but the drama was a little bit bigger. But I'm just not that concerned with having the ultimate perfect pie chart. This is completely adequate for testing purposes. You'll notice that when I did this on Excel didn't even write the percents for me. Having the percents written is going to be useful in terms of answering questions about the pie charts. But both of these are acceptable pie charts. You'll notice that I have the comedy in the upper right-hand corner. Excel put it in the bottom. There isn't a right and a wrong spot to put each of the sections. You'll just fit all the sections in the best they can. And if the biggest percent is the biggest region, the smallest percent is the smallest region, I'm going to be happy with that. And that's all I want to say about pie charts. So basically, you have to figure out how big each section needs to be compared to each other relatively. I did that by finding what percentage of the circle they needed to take. I took the number of people in each category divided by the 600 people that were surveyed. That gave me a decimal. I multiplied by 100 to make the decimal a percent. That gave me what percentage of the circle each region needed to cover, and then I just did my best. Clearly not as nice as Excel did, but good enough. Usually you put the category and the percent in the circle if you can fit it, and it makes it maybe a little bit more useful. Last thing I want to do in section 13.4 is homework problem number 10. Homework problem number 10 gives me a pie chart, and it gives me a lot of reading before that pie chart that I need to do before I answer my questions. Most of the questions that involve pie charts are going to involve multiplying and converting percents into decimals. So problem 10 asks where teens work. So this circle graph, our pie chart, shows the percentage of 15 through 17-year-olds that worked in different places. So 700 teens were surveyed. Of the 700 teens, 51.8% said they did retail, 25.9% said they did some sort of service, and 22.3% said they did other. Yeah, that's fine. Oh. It says, if 700 teens were surveyed, determine the number of teens in each category. So I have a pie chart that represents 700 teens. I want to find out how many teens work in each category. And to find out the number that work in each category, it's just a simple multiplication. You take the number of teens that were surveyed times the percent in each category. So to do the number in the other category, so how many teens of the 700 said they have a job that's not service or retail? I take the 700 teens, I take 22.3% and make it into a decimal, which is 0.223. I multiply those amounts. If I take 700 times 0.223, I get 156.1. I'm going to round that to 156. So 156 of the 700 teens worked in an other category. If I want to find how many of the 700 teens worked in a service category, I'm going to take the 700 teens, I'm going to take the 25.9 and make it into a decimal, 0.259, and I'll go 700 times 0.259, and I get 181.3. I can't imagine the author wouldn't want us to round to the nearest person. I can't say 181.3, so I'm just rounding that. And then the last one, how many of the 700 worked retail? I'm going to take the 700 students that were surveyed between 15 and 17, multiply it by 0.518, and when I do that, 700 times 0.518, I get 300, and I'm going to round that to 363. It would be nice if I added these numbers if they added up to 700, because there are 700 surveys. So let me do that. 156 plus 181 plus 363, and I do get 700. So my rounding was forgiving rounding. So that's all there is to do for that particular problem. There aren't very many circle graph homework questions. Problem 9 is a homework question like this, where a circle graph is given that's complete, and you're asked to break the circle graph into its categories. Basically, you're going to take each of the percents, make it into a decimal, multiply it by the total number of people that were represented in the circle graph, and then problem 11 asks you to create a circle graph. So that's all I'm going to do for section 13.4. Hopefully it didn't feel a bit rushed and you feel good about it. If not, I can definitely spend some time with you one-on-one or in class and clean up anything that I didn't do properly.